Hello everyone, this is Alistair here, and today's problem of the day is titled Exactly One Swap and it involves strings operation. So let's have a look at the problem. The problem states that we are given a string S and it contains lower English alphabet characters, and our task is to calculate the number of distinct strings that can be obtained after performing exactly one swap. So the key here is we have to perform only one swap and not uh, find out all the combinations possible. So there are two approaches to go about the problem. One is the naive method and another one is the efficient method, obviously. So first let's understand the problem itself. Uh, you are given a string S over here, and you have to basically calculate all the different distinct strings that are possible after swapping one character with another. So in this case, there are six different strings possible. Now, in order to go over the problem, let's have a look at the example geeks. Here in this case, if we consider the name method, what one can do is one can traverse over the string and then consider every other character and swap them and basically maintain a hash map to check if that particular string has already been considered or not. For example, if I take G as the starting character and then I basically swap it with E, and I'll store the resultant string inside a map and I'll increment the count uh, if that particular string is already not present in the map. And if it is present, then I'll simply skip that particular string and I'll do so for every other character. And using this name method, I'll be able to find all the distinct characters. But since we are looking for a solution with time complexity of O of n, where n is the length of the string, we'll have a look at another approach. The second approach is uh, we can calculate the frequencies of all the characters present in the given string. And for that, we'll maintain a array of 26 characters, 26 characters corresponding to the 26 small letters, and then we'll iterate through every other character for the given string and basically maintain the count for every character. And after doing that, we'll calculate how many possible swaps are there. And in order to do so, what I'll do is I'll take the length of the string, which is n in this case, that is phi, and I'll basically subtract with the count of this particular character. So in this case, G here has the count 1. So I'll subtract 5 minus 1, which gives me 4. And this gives me the idea that G can be swapped with 4 different characters within the given string. And we'll do this for every other character. After doing this, basically we'll increment this particular count for every other character and store it in a variable. After doing this, one may also have to consider that uh, after performing every operation for every character, there might be duplicates being considered. And in order to handle that duplicate, we'll simply divide this answer variable by 2. And this is because if you consider G being swapped with E, in the next iteration, we'd also be considering E being swapped with G. And that should be eliminated, and in order to do so, we'll simply divide the answer variable by 2. Now that is done. Also, we have to consider another case wherein we have repeating elements, and repeating elements, if they are swapped with another, it would result in the same character. So for example, I have a string called uh, geeks with an additional k and two more e's. All right, let me enlarge this. So if I consider this E and swap it with this E, then it would result in the same distinct E, right? So I'd have to just increment the answer variable by 1. and if I swap k with this k, it would still result in the same string, and it wouldn't make any sense to again increment it by one. So for every character whose count is greater than or equal to 2, we would only increment our answer variable by 1, and we'll then be considering that edge case as well. So I hope the explanation is clear. Now let's move on to the code. So first we'll maintain the length of the string and store it in n, and we'll also create a frequency array wherein uh, we'll store the frequency of the characters for the string s, and I'll simply create an array. And since, as you can see, an O of 1 auxiliary space is expected, and since this frequency array will be constant throughout the test cases, we will be considering this to be O of 1, and we'll initialize the array with all zeros. Now we'll simply be taking the count of individual characters for each of the individual characters within the frequency array. So I'll loop over and I'll loop over the string and store the frequency. Now since frequency is based on index 0, I would have to either multiply it by either subtract it by the character a or the number 97, since a is has the ASCII character of 97, ASCII value of 97. So after this is done, I'll create a answer variable long answer, initialize it with 0, and I'll loop over the characters again, and herein we'll include every character and find out every potential swaps that can have. And for that I'll be subtracting my n with the frequency of that character. Also after this, as I've explained before, I would also have to eliminate the duplicates, and in order to do so I'll simply divide it by 2. Now this is handled, and also to consider the elements where there are repeating characters, I would have to loop over the frequency array and not the string. You could do it either way. Yeah, greater than equal to 2. If any of the character is greater than equal to 2, we'll simply increment it by 1. And this would only occur if there are repeating characters. If there are no repeating characters, then we need not worry about the case, and this loop basically won't go through and our answer would not get incremented. So we'll do this once and then we'll break out of the loop. I guess we are done. We can now return the answer. Let's have a final look. Yeah, this looks clean. Oh, my bad. Alright, that was the problem, guys. So if you have any doubts, you can comment it out in the comment section. And thanks for watching.